Hello guys, so today we are here to solve this, very famous problem called walls and gates. And this problem is, there are many solutions, many well-known solutions to this problem. But I'm going to demonstrate a backtracking solution to this problem. And this solution is really very interesting. And if you are dealing with cells, this kind of grid cells, then backtracking, obviously it comes as an obvious method to attack these problems. And the solution of this grid cell problem, we will do, and we will try to show you how to achieve the solution using the usual backtracking method that we have. And backtracking is nothing but selective recursion. It's doing recursion in a wise manner. It's not just blind recursion on each and every possibility. It's doing recursion only when the proposed know recursion leads us to the solution set. If it is leading to some um, some some solution thing which is not acceptable, then it is then that is we don't go down that path. We terminate our search in that path, and we only go down a path when that path, you know as long as that path is uh, is promising. But as soon as it becomes non-promising, we rule that out. So let me show you how to how are we going to do this recursion. And this recursion is basically it will be involving DFS. So let me show you. Okay, so to do this recursion, we will be creating one more parallel you know parallel grid of Boolean grid. And will be uh, that Boolean grid will be storing the values of true and false for each cell. And if a cell value is true, we'll be searching for that. If it is marked as false, then we'll not be going down that searching on that particular grid. So let's for that we need to define that Boolean grid. So let's do this Boolean. Okay, and we'll name this as rooms bool is equal to new uh, Boolean, and this will be equal to rooms dot length, rooms of 0 dot length. So these are the two things which we have declared. So rooms dot length is the number of rows this given rooms has, and rooms 0 dot length is the number of columns in the 0th row. So right now we are assuming that it's perfectly, rectangular grid, m cross n grid. So for that we are doing this, instantiation of rooms array, Boolean grid. And now we'll start two loops. For and I is equal to 0, I, I less than rooms dot length plus I. And then within that, we'll be doing for and j is equal to 0, j is less than rooms of I dot plus j. And we'll put one check if rooms of I j is equal to 0. Then what we'll do that we'll do one, we'll instantiate, we should not do this. We'll instantiate one method call. Okay, and that method call is visit rooms rooms DFS. So visit the rooms in the DFS way. We'll be taking the rooms, then I, then J, and then the rooms bool, and then the distance. So as of now, the distance is 0. Okay. So with this, we will, And now we are up to declaring this private void visit rooms DFS, and in that we will do one int array rooms int row int column, and then we'll be doing one boolean rooms bool, and then distance, and distance will be an int. Okay, so we have declared the corresponding parameters, and then if row is less than 0 or row is greater than rooms dot length, so row is greater than rooms dot length is equal to, or call is less than 0, we have to write rooms, not rooms dot length, call is less than 0, call is greater than rooms of row dot, call is greater than rooms dot length row dot length greater than equal to, not just. Okay, and uh, so in the problem condition, you have to also take into account this condition that the room is of m cross n grid, and the possible values in the grid are -1. So -1 means that it is a wall. So whenever a wall is there, we will not be able to cross that uh, that room. So if it is equal to -1, okay, or the rooms of row call is equal to 0, and distance is greater than 0, then in all these cases we'll be doing just one return. Okay, otherwise what we'll do, that we will we will uh, we will mark that rooms of row and call with the value called, if so, no need to do this. We will mark this as distance. Okay, and then rooms bool of row and call is equal to false, and then if, so now we are going to the iteration of the neighboring cells like upward and downward. So how we can go to the cell which is upward to the current cell, that we can do it through row -1. So how we can, so we will do row is less than, if row, so will we know row -1 will do. So what conditions we can, what conditions we are going to check, row -1 should not be less than 0. So if row is less than, if row is less than, it should be 1, minimum it should be 1. So row is 1, row -1 is less than 0. So row is greater than, we can make it row is greater than 0. Row is greater than 0. So greater than 0 means it is either 1, 2, or 3. So whenever it is 1, then the least value it can have is 0. So 0 row -1 is fine. And then what else? Row greater than 0 is there. And then we have to check rooms of row call. Rooms of row call. Rooms of row call. Rooms of row call. So 0 rows of row call like that, and then less than. then we'll have to check if this value is, rooms of row call is less than distance plus one, then we are allowing the, uh, recursion, we are allowing our recursive call to be made. And how that recursive call will be made, visit room DFS, so we'll pass the rooms and then row minus one because we have taken the condition. Row, yeah, and then call will be the same, and then distance will be distance plus one. And I think we have, we need to declare the rooms bool, and then distance plus one. And then row plus one is row plus one. Row, so row plus one should not be, less than rooms dot length. Okay, so row plus one should be less than rooms dot length. It could, row plus one could be either rooms dot length minus one, and rooms of row plus one, row plus one, which is distance plus one, get room DFS, rooms row plus one, call rooms bool, distance plus one. Okay, and now something similar we are going to do if row, no, call is greater than zero and row minus one we have to do here. Row minus one and rooms of row call minus one is less than distance. It should not be less than, it should rather be, all these things should be, rather be greater than. So when they are greater than, then only we are allowing this thing to go down. Distance plus one, and then we need to copy this call. So we are taking this call minus one, so we'll take call minus one, and then if row plus one, call plus one, call plus one is less than rooms of row dot length, and rooms of row of call plus one is equal to distance plus one. At the end, what we'll do, that will mark it as rooms of bool of row call is equal to true, so that this cell is again, we are looking, considering this particular cell again for, next round of iteration. So let's do this. Perfect. Perfect. So this is the way to solve this problem. Let me know if you have any doubt. I'll definitely try to help you out. This logic is little bit, involved. But I would like to explain that here we are using, backtracking. And suppose if I explain you with the example of a cell, then what happens that here we are, so let's say this is a gate. Okay. So on this gate, when we are starting the, we are calling visit room DFS. So we are coming to, in this, and here we are saving the value 0 because distance is initially 0. And then we are marking this as false. And then we are, going row -1, but row -1 cannot be visited because this condition row should be, it is less than 0, so we are returning. So then we are going row +1. So row +1, we are marking the distance as distance +1. So here it was 0, it is now becoming 1. Okay. And this is a wall, this is -1, so we cannot go into this cell. Okay. And then we come to this point. That when we come to this point, then again, we are coming from this point. So this is, call -1. So this is +1. So this is 1, and then this becomes 2. And similarly, if you go on this side, so this is call +1, call +1. So call +1 call will be coming from here. So it will be, 0. Here it will be 0, and here it will be 1. Like that will be, keep on filling. So if you go down, keep on going down. So it will be 1, 2, 3. And after this will be finishing, then it will be coming down to, call -1. So call -1, it will be, this thing. So we cannot go down because this is -1 on this cell. So we cannot go this path. Then it will come down, then we'll figure this. So 1, 2, 3, and then there will be 4. So like that, this is the distance from this point. Okay. And once it will go here, and then it will fill all those paths. And here it will not mark it, any value. It will, return because we are putting this condition, rooms row call is equal to 0 and distance is greater than 0, then we are returning. So in this cell, we are checking whether rooms row call is equal to 0 because this is a gate cell. So gate cell, the value will be 0, and the distance when we are calling this for this gate, then this distance is much more than 0. So we are returning. But otherwise, all cells will be given some values in the first adjacent cell. Now, when we come to the second gate, then again we are filling it. But this time, this distance from this gate is smaller than this distance from this gate. So we are filling this distance. For this cell also, we are filling this distance. And for this cell, any distance, this distance from this gate is nearer. So that's why, and for this distance from this gate is nearer, so we are filling this distance, and we are removing these older values, larger values. So like this, we are, completing this traversal of the loop. Here we could have used breadth first search, but this solution is as good as, anything. So thanks a lot. Thanks a lot for your time. Still, if you have any doubt, definitely post it in the comments, and I would love to answer those doubts. Thanks a lot.